Okay, so good evening. How are you doing? I'm going to try to do a quick recording just to do a quick explanation. I do apologize that I wasn't able to give time for a one-on-one meeting. So I'm just going to go ahead. I'll start off with the OGP document, then we'll go to the part count, and I'll show you a sample frequency analysis. So let me share my screen. I think this is what I want to share. So I hope you can see my screen. So, okay, so I'm going to start off with the OGP. So looking at the OGP, you can see that it will process release frequencies. So you want to know how to merge that with your pad count to do a frequency analysis. So basically, the important tables, sorry, I'm not one of the most patient people on earth, are these data sheets. That's where you want to focus on 2.2. Of course, it's a great read. You can read through everything, read through application of data, etc. But I really honestly cannot spend the time at this point. So the data sheet is more or less like the meat of the matter. But please take some time later to read the full document so you have a good context of what you're reading, of what you're working with. So I want to make it bigger so everyone can see. So these data sheets, I'll explain how we use them. So for the first one, we have steel process pipes. Steel process pipes. And if you look through the definition, they've explained what they mean offshore, what they mean for offshore, what they mean for onshore, and they tell you what's included, and there's a reference. So if you look, it says steel pipe work per meter year by pipe diameter. It's based on, so you see meter year. So that's why it's important for you to, when you're doing your part count, to do the counts, because you need to more or less normalize it to frequency per year. So for pipe work, you're looking in terms of length and all that. And so this first data sheet is based on 2006 to 2015 data. So if you look, so you basically come to this table, but but I don't want to spend a lot of time on the pipe work because we don't have quite a lot of pipe work that we're looking at in your part count does not have quite a lot of pipe work. I don't want to spend too much time, but if you did, this is the table you use for your frequency analysis. But I don't want to spend too much time there. I want to go to something that you can relate with. So this second table is for data based on 1992 to 2015. So if you read through the parts of the document that has kind of skipped, they explained why they segregated between the one from 1992 to 2015 and the one from 2006 to 2015. So there are flange joints. Can look through what the flange joint is. I want to kind of zero in on the manual valves because I think that's an entity that is easy to count. And I also want to show you something that you should probably go and correct on your part count. So for manual valves, again, you decide which of the tables you want to use. Do you want to use the one of 2006 to 2015 data, or you want to do 1992 to 2015? Please read the body of the report, the OGP report, to understand and make the right decision. There's no correct one and there's no wrong one. So basically, if you want to use this table to get what we're looking for, this is really where this part we want to focus on. So you're looking at the whole diameter range. 1 to 3 mm, I believe, is considered to be a small leak. I think 3 to 10 is, I think, a medium leak. I can't remember. I think between 1 to 10 is a small leak. But sometimes they just want to segregate and keep the 5 layers Then you have 10 to 50, which some people look at as medium leak. Then 50 to 150 mm is considered to be what they call it, a large leak. Anything greater than 150 is considered to be full rupture. Okay. And then so what I want to point out on your own parts count is that and I'll open it up. So you see in this table we have 2-inch diameter. So we are counting the number of 2-inch diameter or less manual valves that we have. Then we're looking at anything between 2 to 6, greater than 2 but less than 4 to 6. That's what we're looking at here. So so I'm looking for how to explain. So you need to multiply. So if you've counted, so let me go back. Let me open your part count so that I can explain to you what I'm trying to say. Stop share. So let me share the part count document. Where's that now? Where is it? Where is it? I'm looking for it. Apologies. It's taking a bit. I think I need to try it again. Okay, so it's here. So I hope you can see the screen. I really hope so. So so if you look, so let's go quickly to the manual block valves. You see, you've started your own count for diameter less than or equal to 3 inches and you counted 7. But if you look at the OGP data, you're going to have challenges with matching this with the OGP data because OGP is looking at 2-inch and below for one category. Then you have anything between 2 to 6 as another category. Then you have anything that's 12-inch and below in another. So I think you need to go back and do your part counts to match what you have on the OGP table, because that's we are going to multiply the frequency you have from OGP with the number of parts that you have counted from what they call it from your design. That's it. So I'll be happy to answer any more questions. But basically, what you're doing is that you're counting, for example, the number of 2-inch and below manual valves, and you're multiplying them by the frequency numbers that are in OGP. So yeah, the last thing I'm going to do is I'm going to show you an Excel sheet of the sample frequency analysis that I did last year. So let me stop sharing this. Let me show you a sample frequency analysis. So this is sample frequency analysis that was done. So so first of all, we broke. So the other thing I was going to say is that when you're doing your frequency analysis, you want to, basically even for your consequence analysis, you want to break your system into what they call it, into nodes, smaller nodes, more or less like what you do in the hazard. So you also want to have isolatable sections. So your typically the isolatable sections you use for your frequency and consequence analysis is usually similar to the nodes that are used for the hazard. So you don't want to count all the manual valves in the full design. You want to break them and you use, because you're trying to look at consequences from different areas of a design. You're not looking at it as one design. That's the other thing I just wanted to point out to you. So you have to have sections, isolatable sections. So here we had divided into 5 isolatable sections, and of course there's a transition for that for the people on the project. They would understand. And so in section 1, we had checked how many manual valves less than 2 inch do we have? We didn't have any. less than or equal to 2 inch. Then we counted how many manual valves we have that are less than 2 inch, greater than 2 inch, or less than or equal to 6 inch. We counted 5. I know, so we did the part count that way. And so this is the sections with the part count. Then we also had to determine how for vapor, because it was a gaseous system we're dealing with. So this was the number that we had. And you know, the 0.5, you ask why you have 0.5 activated now. It's, you have to go to the OGP to understand why we are having 0.5 at some point. But anyway, we've done the part count. And so what do we do with this data? We have the OGP data, as I showed you before, we put it in Excel. So to do the frequency analysis for the vapor phase, what we did was that we multiplied so for example, for a 1 to 3 inch leak size, to know the 2 inch. So let me go to the frequency analysis tab. So, and we are under let me come to the manual valve section. So question is, how did we get this 0 that we have here? So if you look in here, you see that we went to the tab called OGP N3. Let's see what is in OGP N3. So this is OGP data N3. So this is N3 here. This is N3. And what is this number? We're basically taking the OGP data for 1 to 3 leak sizes for 2 inch and below manual valves. And what did we multiply it by? We multiplied it by summation VAP, this tab. We used the J3. So let's see what's in summation VAP J3. So this is J3. So you see here, we multiplied by the number of manual valves we have there, which was 0. So that's why you have a 0 here. So after we've done, so you know, we went through for 1 to 3, 3 to 10, 10 to 50, 50 to 150 and greater. So when we're done with that, we now summed up all the numbers here, summed here, here. So we summed up all the numbers. What did we do with some numbers we summed up? We are adding, it's additive. So when you get the possibility of a 1 to 3 inch link, millimeter leak on a 2 inch valve, manual valve, you add that to the 6 inch, to the 12 inch etc. And in different places, you come up with a total here. We've looked at all the possible area sources of 1 to 3 millimeter leak sizes. It's additive. So you add those and you compare that with, you add, so basically you add for all the other leak size possibilities. So if you look, so we've done like a percentage analysis, you can see that most of our leaks, as in terms of percentages, the highest percentage is the 1 to 3 millimeter leak size, which is consistent with what we see in nature. Then you have the 25 point, the next one is the 3 to 10. So you see that by the time you add these two, it's going to give you about 80-something percent, 83.59% of your leaks are going to be small leaks. So we're able to say that that's perhaps the one that we should focus more on. But of course, some people will still ask that we still want to look at the high consequence, low frequency in the cases. So we still look at the other ones anyway. But we'll probably focus more, and in making our design decisions, we want to focus a bit more on the small leaks. So I think this spreadsheet should explain to you how we arrived at these numbers. So please feel free to ask me your questions at the end. Thank you.